Happy Wednesday. Three things to go through tonight, section D, E, and F. Section D, I believe, is measure of position.
I have a question. Do we have a book for your class?
It's
I
online.
Okay, everything's online?
Yes.
Okay, thank you. Because I just picked the class up.
Oh, it means I lost someone because the class was full last week. Welcome.
Hi, thank
Don't forget to scan the QR code to get counted for attendance.
Okay, thank you.
You do that when you come in and when you leave. So measure of position, where? Don't worry about it. It's too late now anyway, but it doesn't affect you that much.
Okay, perfect.
It
Thank
won't
you.
affect you at all. So measure of position, we're interested in where a data point is located with respect to other data points. The easiest way to measure this is with what's called a z-score. So z-score will indicate the position of a value with respect to the mean. It expresses how many standard deviations above or below the mean that the data point is. They also give a way of comparing data sets, two different data sets that have different means and different standard deviations. So you're going to learn that we mathematicians, we statisticians are assholes. So here's the example I'm going to use. You're female and you want to determine, are you overweight for the average female? Well, you wouldn't compare your data to the average male weight, would you? No, right? You'd use the average female weight. You calculate the z-score for that. If you're a male, say we have male and female, we're going to determine how they compare with respect to the average. You need the z-score for the male, the z-score for the female, and that's the score that you would use to compare the two. Same thing with heights. Generally speaking, same thing with class scores. If you know your class score average, or the class average, the class standard deviation for all of your classes, you could use z-score to determine which class you did the best in with respect to the average. The higher the z-score, the better. Right, positive z-score obviously means that you're larger than the mean. Negative means you're smaller than the mean. If you have a z-score of 0, that is the mean. A z-score of 0 is very, very, very rare.
I have a question. Are you getting notes on Blackboard?
Not right now,
Okay.
but I do
But
post
they
them
will be-
afterwards.
Okay, thank you.
You have to scan it before and after, when you come in and when you leave. For population, x minus mu over sigma. For sample, x minus x bar over s. That's just two ways of saying your z-score is just your data point minus the mean, all divided by the standard deviation.
Does it matter which one you use for either positive z-score or negative? Or the formulas as well?
The formula just determine is it a population or a sample. I don't even know why they have two different ones. It's just data point minus mean divided by standard deviation, regardless of whether it's data from a population or data from a sample. Z-scores will come into play later. They're very important when we start studying probability theory. Another common way to determine position, to measure position, you're probably familiar with. Percentiles. Percentile indicates what percent of the values in the data set are below a particular data value. I'll use this example. Newborns. Yes, two of them within the span of a year, so I'm very familiar with this. You have to go in for checkups. Right? It's like every month for the first 3 months, then it's like every 3 months, then every 6 months, and then eventually every year. And then they give you weight, height, head circumference with a percent. That's the percentile. My son was ranked in the 99th percentile when he was young. That means that 99% of males his age were lighter than him. There's only 1% heavier. 50% would obviously be the median, the average, essentially. Kth percentile is denoted as P sub k. And it's the value such that k% of the observations are less than or equal to that value. Median is P50. It's the 50th percentile. A special type of percentile are known as quartiles, just as they sound, quarters. The 25th, 50th, and 75th, denoted Q1, median, and Q3 respectively. I will most likely wind up accidentally using Q2 for the median. So that's what I use in my statistical analysis classes. Used to determine the shape of a distribution and are used to determine if the data set has what are called outliers or extreme values, which are data values that differ significantly from the other observations. individual values. And extreme values are significant. They can drastically affect your analysis. Depending on what you're analyzing, you're better off getting rid of outliers. So again, depending on what it is, typically if we have outliers, we'll just discard them from the data set and then analyze what's left. Finding percentiles. Yes, because of course there's going to be calculations involved. First thing you want to do is order your data set from smallest to largest. I'll call this the ordered set. Calculate the value I, which is k over 100 times n plus 1. And obviously k is the percentile that you're looking for, n is your size, sample size. If I is an integer, the kth percentile is the data value located in the ith position in the ordered set. It's not an integer. Round it up to the nearest integer, round it down to the nearest integer. Then your kth percentile will be the average of the data points in those two positions. Right, so let's say I winds up being like 10.036 or something. You take the average value of the data points in the 10th and 11th positions, and that would be the kth percentile. Five-number summary. Use the summary a lot. Five-number summary is the minimum, Q1, Q2, Q3, and the maximum. So the 0th percentile, the 25th, the 50th, the 75th, and the 100th. Again, or Q0, Q1, Q2, Q3, Q4. Your interquartile range, the IQR, is the difference between Q3 and Q1. Right, so it's Q3 minus Q1. All right, so I already mentioned what outliers are. It's a value that is either considerably larger or smaller than most of the values in a data set. And they can affect certain values like the mean. How do we determine outliers? We need what are called boundaries or fences. These serve as cutoff points. Lower fence, Q1 minus 1.5 times your IQR. Upper fence is Q3 plus 1.5 times IQR. So in general, any data point that lies below the lower fence or above the upper fence would be outliers. At least that's how I learned it in grad school. She includes 2 other fences. Lower, lower, and upper, upper, which is the same thing except it's 3 times instead of 1.5 times. Anything that lies outside of that, she calls an extreme outlier. Now, so far, we've spent our time with values, right? Finding values that analyze this data set. But we haven't actually looked at visualizing it, displaying it. Let's rectify that. One of the most common graphs to use when displaying data is called a box plot. It's a graphical display of quantitative data. And you can create it using the 5-number summary and outliers. It's useful for comparing two or more data sets. How would you draw a box plot? Okay, but how do you draw the box?
Is it like a rectangle? Or like two lines, you know?
Then how would you do it? The obvious answer is let a computer do it for you. Right? We're in the technological age. Just enter your data into a program like Excel and just go, box plot. And it gives it to you. Which is really nice.
I have a question. Box plot is like a cube, right? With the circles. No?
I mean, I guess that would probably be a three-dimensional box plot.
Oh, yeah.
But let's pretend we're back when I was in school, the Stone Age, and we didn't have computers. So we had to do it by hand. Or let's say it's like a test question. You're not allowed to use a computer. First thing you want to do is draw lines at Q1, Q2, and Q3. Then you draw your box using those lines. Specifically, you're going to draw a rectangle where you have two parallel sides, Q1, Q3, and then your adjacent sides connect those two lines. Put an asterisk at any outlier. Then we draw what are known as whiskers. Lower whisker would go either out to the minimum value or the smallest value that is not an outlier. So we'll just say it goes to the smallest value that is not an outlier. The upper whisker will go, I'm going to set this, you know where I'm at. Upper whisker will go up to the largest value that is not an outlier. And again, that could be the maximum if there are no outliers. And that would be your box plot. You may also see it called a box and whisker plot. This table contains the per capita income from the 50 states. You want to determine the 5-number summary. Okay, so I'm going to have to enter all this data in. I think I saved it.
You think so?
Yeah, I have to check. I did this 2 weeks ago, so I did save it. Now it's not there. Of course not. Why do I do this to myself? And, oh, yeah, it's going to change that display too, isn't it? Of course it is. That's okay. I'll fix it later. shortcut for the slideshow, which is nice. I think that's where I'm at, right? Oh, that one. I am not redoing this, let's quickly save this. And so all 50 values are in there. I'm only going to use this right now to sort the data. So remember, we need a sorted list. So highlight. So where to do it here? There is. And so data, sort, smallest to largest. Okay, now sorted. For right now, that's all I needed Excel for. Oops. Five number summary. Who's paying attention? Saw your hand first.
Minimum's Louisiana.
Oh, I don't care about the state. So minimum, smallest value.
24820. The Q1 is 30,553. Median is 36,120. Q3 is 41,760. And max is 47,819.
So how'd you find Q1 and Q3? I'm gonna like you. That's always the answer. How'd you find it? Math. I'm gonna start using that. I'm just gonna put up an answer. How'd you know that? Math. Yes. Except mine won't be basic. It'll probably be like Calc 3 or something. Right, so yeah, the five number summary. Minimum, Q1, median, Q3, and maximum. Minimum, maximum, very easy to find, right? That's why I had it ordered. So there's the minimum. There's the maximum. If I remember correctly, isn't the maximum New Jersey? What is it? Really?
Medicare, Massachusetts.
New Jersey is a 43,771.
Yeah, that's not bad. Except for one problem. Yeah, it's great. New Jersey also has the highest property taxes in the nation. So cost of living is. Oh, I guess that does make sense. Connecticut does have a pretty high cost of living. California.
Cali, yeah.
Cali's the highest.
Yeah.
And they're not the highest. Start. How do I want to write it? Do I want to write it in column or row form? I don't think I have room for row. Is the 2, 4. Let's do this. I'm going to go in order, so I am going to find Q1 next. was the formula? What do we have to do?
Broaden the summary.
First, calculate that. No, this will be fine. So let's get a new slide in here. Use for calculations. $25 over 100 times 51. Well, 25 over 100 is just a quarter. So it's 51 over 4. Is that an integer? No, it's not. That's actually 12 and a half, I believe. 48 would be 12. Oh no, so it's 12.75. 52 is 13. Which means we have to take the data point in the 12th position and the 13th position and find their average.
So it would be times 51, right?
There's 50 data points, I have one. Just going to highlight those two for now. So that's what we. Is it not showing the highlight? Are you serious? If I leave the screen, it really doesn't do it. Okay, I can easily fix that. I win. Because now if I leave the screen, it stays yellow. I don't want to break my neck. What was the 12th data point?
29387.
What was it?
29387.
29387. And what is the 13th?
30267.
Now what Excel's giving me. Oh. Sure, you have the formula, right? Looks like I did. Yeah, no, my formula's definitely right. Yeah, 12.75, so I want 12 and 13. That's interesting. What if I do this in Excel?
Celebrity you have.
That still doesn't give me the So I got for that average
827.
29827.
Oh.
Which is not what Excel gives you.
So I subtracted the minimum from the median, divided it by 2, and added it to the minimum or subtracted it from the median.
What did you get again?
3553 for the 13th.
Yeah, that is also not
13th.
what Excel gave.
Yeah.
So I wonder if it's a more complicated formula, and this is just a simple formula that they're giving for right now.
Is it the 12th data set?
It's the average of the 12th and the 13th is what you need to take. I'm just going to stick with that for now. I'll also see what Minitab gives because I've been playing around with Minitab.
I have a question. How can Excel be the different than the actual?
Because that's probably not the actual formula. That's probably just a simplified version of the formula.
Because I see when you put it back up, it said +1, so I thought my answer was wrong.
It's n plus 1, number of data points plus 1.
Okay.
So we have 50, so I need 51. I'm just gonna use that for the by hand calculation.
Yeah, that's easy.
29,827.
827.
Median's also fairly simple. So now I want to get rid of you. What's 50 divided by 2?
25.
Oh, right, you can't do that, can you? It's only if it's odd. So it's the average value of the middle two numbers, which would be 25 and 26, right? Should be the average of those two. What's half of 51? 25 and a half. Yeah, so it's the average of 25 and 26. That's what, 32,478?
32,836.
Which is what Excel gives as the median, so that's nice. At least I agree with something. I is going to be 3/4 of 51. One can see 3/4, which is not a whole number. So 38 and 39. Three eight one five three.
36,153.
36153 plus
36,778.
36. What was it? 778. All over 2. 36465.5. And then obviously the max. 47819. Question 2 is just to make a box plot. We want to determine if there's any outliers. First, we need the interquartile range, IQR. Q3 minus Q1. We said Q3, 36465.5.
On 29,827. $6,638.5.
There's your IQR. Lower fence. Q1 minus 1.5 times IQR. $19,869.25. What was the minimum?
24,820.
So there's no outliers on the lower end.
How can you determine an outline?
Values less than that would be an outlier.
Okay, thank you.
And then the upper fence, Q3 plus 1.5 IQR.
3646. I'm sorry, 36465.5.
Four six four two 3.25. What was the maximum?
470.19.
So we have at least one outlier on the higher end. I'm just going to list all the outliers. Obviously, the maximum is going to be an outlier.
Yep.
47819. Any other?
No.
Nope, that was the only outlier. That's nice. Okay, now for the box plot sketch. And it is a sketch. It will not be drawn to scale. Start with a line at Q1. All right, so 29827. Draw a line at Q3. 36465.5. I'm just going to try to finish that box right now. Line at the median,
32657.
32657, which is closer to Q1. It's about 4,000 away from Q3,
True.
and only about, what, 3,000 away from Q1. So it's not going to be directly in the middle. Maybe like there. Three, two, six, five, seven. So we had no outliers below. So the minimum was 24820. Maybe right there. There's the lower whisker. Upper whisker. So we did have an outlier. The max was an outlier. So we'll go to the largest value that is not an outlier.
20. No.
3646.
Yeah, that.
Four, 289. It's the largest value that is not an outlier. Oh, that's going to be like way up here somewhere. And now we have an outlier at 47819. Right, so again, not drawn to scale. It's just a rough sketch. That's if I draw it vertically, which is the standard. You can also draw it horizontally, right, which obviously be the exact same thing, except you're drawing it with respect to the horizontal instead of the vertical. me show you how to do it on Excel. And again, it's going to give different values, again, probably because the formula we're using is an oversimplified formula. The beautiful thing with Excel is you don't have to order the data set. Now remember last Wednesday, I showed you can name an entire collection of data. I already did that. So I highlighted A1 through A50 and called it salary. So that's what I'm referring to.
Have to put the data in before you name it.
Yes.
No,
Well,
it's not.
not necessarily, but you have to highlight the cells to name. So I suppose you would probably highlight the number of cells you need first, name it, and then enter the data. That's fine. All right, so if I do this, let's see what happens. I'm going to test. Actually, I forget what I just highlighted, but whatever.
On this last week, notes, are they on the blackboard?
Yes.
Okay, thank you.
Yeah, so you don't actually have to enter data, right? It's still highlighting equal test. That's what was named as test. So that's the array that's test. Just gonna get rid of that. So we're just going to assume that it's not ordered. Find the minimum, just equals min. And this is true for any percentile. Obviously, we're doing Q1, so we're going to do the 25th percentile. Percentile dot .inc. Generally speaking, you want the inclusive one, not the exclusive one. The old formula was just percentile. And I have verified that both percentile and percentile.inc give you the same value. Your array, comma, and then the percentile you're looking for as a decimal. We're on the 25th, right? What's 25% as a decimal? What is it?
0.25.
Okay. No. That's why I box plot for myself, what you think.
Median is just equals median, and then your array. So there's the 75th percentile. Max. It's just max. That would be your 5-number summary. I don't think there's an option to do the 5-number summary. If there is, it's an add-on that I haven't found yet for Excel. For the box plot. So,
For my max, I got 56,380
for what?
for my max.
Well, that's not good, because that's not even one of our data points.
Oh,
So there's no way that can be the max.
true. I think because I added something.
Maybe you typed in a data point wrong or something.
Maybe,
That's why I went back and I checked, because I thought maybe I entered a data point wrong in Excel. Or when I was doing it here. No, I didn't. I got the exact same thing. So I have no idea. Box plot, insert. Whole lot of options. We want that middle one right there. Unfortunately, it doesn't have a command bar. All right, so follow my arrow. You see this charts option right in the middle. Box and whisker. Now, there is a problem because I don't have anything highlighted. So generally what you're going to do is highlight your data. You can change it after you create the plot. And then design, you can always change stuff around. So quick layout, I like this one. Use that. And I personally remove the axes, I don't like them. You can leave them in, that's fine. That rate, oops, not the title, the actual axis itself. I think you can add grid lines too, yeah. You can also add the grid lines to make it easier to see. You can change colors. And if you double click on it, brings this up, fill, and I can then change the color to whatever I want. Kind of makes it easier to see what's inside. And I actually have no idea what that value there is. Got 33442.08, I have no idea what that is. Probably, now that I think about it, that might be the average. Excel might throw the average in to the box plot.
so we're going to be using Excel a lot in the class.
I will be.
Oh, you.
Yeah, 33442.08, that's the average. Okay.
Yeah.
You can also use it for the homeworks, but for the projects, she does require Minitab. But I actually, she details how to do each problem in Minitab, so shouldn't be too difficult. Just follow the instructions. Honestly, I've actually started working with Minitab. It's actually not that bad. It's fairly easy to pick up. All right, so that's Excel. Speaking of Minitab.
So like the whole, is it like a course book like online, right? And then it tells you if you got it longer, right? No?
That's her notes.
Oh, it's good.
else is showing? Web. Oh, it's blocking this out, it looks like. That's actually very interesting why it's blocking that out. That's what it's supposed to look like when you first open it. So why OBS is not showing that middle panel, I don't know.
Is that in the 360?
No, this is Minitab. This is what you don't want to do just yet
Okay.
because it's a free trial that you're going to be using.
For the project one?
So wait till project one, until you're actually doing project one to start the free trial, because I don't know how long the free trial is. And I saw your hand. I have no idea how long the free trial is.
You will need it.
For the project, yes. So just wait till the project to get the free trial. And again, there's instruction that goes up. I think that's assignment 3, so that'll go up next week. That tells you how to get the free trial. Minitab is also available, they say, on some of the computers on campus.
Is this the project?
No, I'm just using Minitab right now. So I'm going to just kind of raise this. All right, so down here you see it looks pretty much identical to Excel. Except this first row is always a title. You can title your columns. So let's just title this salary. And then you enter your data. Now, if I copy and paste from Excel, will it let me do that? If not, then I'm not doing this, because I'm not retyping in all 50 values. Yay! It does let me copy and paste. Victory is mine. So that's nice. I don't have to redo that. Oh, worksheet 1? No, I don't need you. Worksheet 2.
I'm sorry. This is 1851, like as in 1,000.
Yes, that's why I said use the free trial and wait.
What?
The only reason I'm using this is because they gave me a license. I mean, that's more expensive than Mathematica used to be.
So this is a temporary subscription?
Yearly, yeah.
I'm lost.
Yeah. Then why do you think I don't?
Catch me up.
I don't want to use it, but I have to. So use the free trial.
In my jaw.
Yeah. How do you think I did? What do you think I did when I first looked? Because I was going to buy a license. I thought, whatever. It's not going
How
to.
much was it? 1,800.
Yeah, it's almost $2,000 a year.
Crazy.
And that's for a single license. That's not even for like a company license. One license.
Wow.
Single-use license.
91.
So no thanks. I'll just not do that. Now, I think I can do. Cool. Yeah. So I can actually, under Calc column statistics, it does give you an option for this kind of stuff here, right? Some mean, median, or some mean, standard deviation, minimum, maximum range. Medium's there. Gives n total, all that. Doesn't give quartiles, which is interesting. I'll probably just do calculator though. Yeah, if you do calculator, percentiles right here. probably have to actually type it in this way. No, huh? Invalid variable. What's going on? Oh, still results in. C2, there we go. And they got 30,047. Which is still not what we got by hand. So, yeah, there's definitely some wonky with the formulas going on. Honestly, I find Excel better for the calculations, personally.
So we're being graded off any tab we should use.
For the project.
We should use whatever comes up there.
Yeah. For the project.
For the project.
Yes.
If we're doing like a test, we should do the hand.
Do it by hand. And that's how I'm going to write my solutions by hand.
Okay.
Graph. And you see a whole bunch of graphs. Look, there's a box plot.
I don't see anything.
Yeah.
Yeah, I was gonna say,
It's not really.
I was wondering what you was talking about the whole time.
I thought you knew that for real.
Cal. Did it show this part?
No, it was just
We just
black.
thought that's how you wanted that.
Like, y'all thought you was just talking to
Yeah.
yourself, but like talking to us out loud.
OBS, okay. So what I'm gonna have to do for this then is. Now I just lost Excel. There you are. I'm going to have to add, not window capture, display capture. Oh, but you'll show that. Okay. But you'll show that. Yeah, thanks. Okay. This makes it really difficult. I don't think it's going to show my what else I want, right? Tab all the way down here, though. Now let's see how this looks if I bring it back up. That's way too zoomed in. Lock, 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 lock. Excellent. Want to hide that bottom part.
This is what we should have been looking at the whole time.
Yeah,
We lost it.
there we go. All right, let's try that again. So at least you saw that, though. So what I did was calculator. I'm going to do right over here. It shows all the different functions you can use. Percentile, and then down here it tells you the command. That's what you type in there. Percentile, which is the same command as in Excel. And show result in, you have to tell it where to show the result. So like, I could do C5 if I went really far away, hit OK. And it comes up there. Now, graph, box plot. Let's do the simple one, okay? Which variable I want, salary. Double click that, click OK, and it should display right there. And if you click it, it gives you a bunch of options that you can do. Best bet probably let's send it to Microsoft Word or something to print it out as an image. I don't see anything on here that says. So save graph as, you can also just save it. If I right click it, no. If I right click it, still doesn't give me the option. I can copy though, copy graphs and whatever it does. Useful. I still prefer Excel. So now we're just going to hide you. I hid screen. Obviously, this problem was written before Twitter was renamed. What, that's now called X.
And that's just weird.
I don't think I'm also not as smart as Elon, so.
Old people change, you just
Some-
call it what you want.
I mean, the dude bought it, so he can do whatever the hell he wants with it. The funny thing is, he bought it simply because they pissed him off. Like, it was just like, oh, okay, you're going to do that? I'm just going to buy it. Started off as a joke, and then I pissed him off. Like, okay, done. Now he owns it.
How can you go down a box on Excel? Every time I hit tab, I go to the next box instead of going down.
Enter.
Thank you, Sean.
Tab moves you horizontally, enter moves you vertically. So number of tweets sent per day for a sample of 30 college students was given as follows. Construct a box plot. Now, chances are for the test, if I give you a data set this large, it is going to be ordered for you. I'm not going to unorder it. Smaller data set, I might have it unordered, and you'd have to order it. This one's already ordered for us without things. Actually, you know what? Start over. Because I want to show you a nice trick. Okay, so let's say you have data points that repeat. So you see that really tiny green box down in the bottom right corner? When you hover over it, notice the symbol changes. Click, drag, drop. It also does it for formulas. Like if you do a formula and it's using certain cells, if you drag it, it'll actually then update the formula for the new cells in that row. Extremely useful. There we go. So now, I now have everything. Yes, and I, for some reason, just didn't start in one. Whatever. So let's name that. Insert, I'm going to insert a box plot. And because there's only one data set, I think it's going to automatically select that. But I can double click. Where's the right click? I may have to right click. Oh, I can actually turn stuff off. Okay, that's cool. I didn't know I could do that. Learn something new. This one. Ah, okay. If you right click, you can select data. Chart range, but not salary. I can just do tweets. Fortunately, it's now showing these data points that I don't want. Double click it. Why is it showing those points now? It shouldn't be. What if I select a point and then delete? Oh, no, that definitely is not what I wanted to do. Data labels, none. That's weird. What did it do? All I did was label it. All I did was select the data. So why did it add those data points? Who knows? Get rid of that, start over. I don't like those data points. Highlight, insert. I like that better. Box plot. And then you can, of course, adjust it.
You did it so fast.
Yeah, I've been doing this for a while. Don't want any title. Let's do to the right. This point, that's IU, back to you. you can not give me designer ideas. Thank you very much. And we'll say there's no box plot. Right, real easy.
I'm sorry, I keep asking you a lot of questions. So you hit insert, and then where do you go? Because I want it up here.
So it's insert,
Yes.
see what charts is? If you're using the web version, it may look different. You need to find charts somewhere.
Yes.
Then you're gonna see one that has a bunch of bars. You're actually gonna see two that has bars, but they should be solid colors. Same color. Oops.
I'm gonna try to learn this right now.
So I'm gonna try to update. This is down. Okay, so this is gonna give you all your options, statistical.
Yeah. Oh, thank you so much.
Sure.
Thank you.
I know that.
Knowledge is a beautiful thing. What's that for? Finding percentiles. That means I have to enter that data. And I don't feel like doing that. Yeah, whatever. Shouldn't be long. It's 32 of them. That won't take me long. 18, there's how many 18s? 2, right? 21, 22, 25, 26, 27, 29, 30, 31. I think there's 231 values. Sevens. Seven, 52, 55, 57, 58, 62, 64, 67, 69, giggity, 71, 72, 73, 74, 76, and 77. Perfect. We want the 37th percentile and the 72nd percentile. I'm not calculating it by hand. Right. The calculation would be what we did for the quartiles. K would be 37. Or is it 31? No, 37th percentile, right? K would be 37. N is 32, right? So it would be 33. N plus 1.
Wait, so we're going back to this part?
Well, I'm just showing you the calculation.
Oh, okay, okay.
All right, fine. I's. Oops, I learned how to spell. Oh, I didn't name this. A1 to A32. If you don't have a name, you just want list of arrays. I know I want, my arrays are A1 through A32. So starting, colon, ending. And it gives you that column. Oh, wait. percentiles. Find P30, oh, here. Yeah, find P37. So what did I do here? No, the solutions are wrong. They actually wanted to find what data point is 37 percentiles 37 in, which we're not going to worry about. I'm just going to do it this way. So P37, 37 percentile is that value, 34.41. And we also wanted the 72nd. Equals percentile dot inclusive, A1 to A32. And it was 72. Point 72. There it is. So doing what I think they intended. So they want to determine what percentile is 37. What position does 37 first appear when it's ordered? 14th. What's 14 over 32? Winds up being 0.4375. Round that up. It's 44th percentile. That's how you determine what percentile it's in. You just find out, you have to order it. What position is it in divided by the total number of data points you have times 100.
So being that it's 32, that's what you divided by?
There's 32 data points in there, yes.
Can I write that down? Go ahead, now you just put, you made it real simple that time. You said it real simple.
So first you have to order the data set. Right? What position is your data point located in? In this case, it occurs twice, so you want the first position. Divided by the total number you have, total number of data points you have, times 100.
I have a question. Where do the 100 play a part?
Percent,
Oh, okay.
because it'll give you a decimal,
Okay.
so multiply by 100 to get percent. And then round it up.
So same thing with the 72?
Yeah, so 72, what I would do is, I know there's 32 positions, I know it's 32, so I start here. 32, 31, 30, 29, it's in the 28th position. So that would be 28 divided by 32 times 100 is 87.5, so it's the,
88.
they have 86 here, but I'd say 88th percentile. For 72, what percentile is 72? So you need its position, right? So
It's 28. Yeah.
you could start here, but you also know there's 32 values. So 32, 31, 32, 31, 30, 29, 72 is located in position 28. So it's 28 divided by your total number, 32, times 100.
Excel?
We do have tests, yes, but it's not coming up yet.
So in that test, we have to use like this or calculator? We
Do hand calculations.
You don't head calculation.
And
So we're not using it.
for the test, you're not going to be able to use Excel. You won't be allowed to use your laptops.
No, but we can use the.
You can use a basic calculator.
Oh,
yeah,
that's what it's at.
That's what I mean by hand. That's what I mean by hand calculations, not like Excel.
Nah.
Well, except for Mr. Mac there, he has to do everything by hand. No calculator allowed for him.
You have to calculate on your phone.
So you have to be fancy and having a Mac.
So I have a question. On the computer, it's like y'all using Excel, that's all? Or did he give you like a link to use for it?
So it's on Blackboard, they have the 360, so they have Excel, have Word,
Okay.
there's a whole bunch
Give
of
me a
applications.
Thank you so much. I'm gonna bring my computer next time.
So question 5 and 6 is the same as 1 and 2. They give you data, find the 5-number summary, create a box plot. So let's just get that. Calculating z-score. Patient recovery time. That's nice. It's recovery. I thought it would be like survival rate. So patient recovery time from a particular surgical procedure has a mean of 5.3 days, standard deviation of 2.1 days. What is the z-score for a patient who takes 10 days to recover? Now here's how I always learned it.
It's
Write the data point as a subscript so that it signifies what we're finding the z-score of. Right, so this is the z-score of 10-day recovery period. Your data point
0.5
minus the mean
5.3
divided by your standard deviation.
4.7 over 2.1. Or 20.24.
And it's not mentioned in the notes, but again, from all my statistical experience, it's two decimal places for z-score. So rounded up, it's 2.238 and some change, so 2.24.
When you do it, like say if you take a test, do you also want like, because 10 minus the 5.3 and 4.7, do you want to see that as well, or it doesn't matter?
Show as much work as you think is necessary. Partial credit is awarded at my discretion. Z-score of 2.24, what's the interpretation of that? So what does that mean?
Standard deviation. I'll follow that.
I agree, it's definitely above, but above what? The what? The mean. How much above? What is it? 2.24 something. What was it? Standard deviations above the mean. So 10 is 2.24 standard deviations above the mean, which we'll actually see soon is actually odd. That is significant. Remember, most data falls within 95% or 95% of data falls within 2 standard deviations of the mean. This is beyond that. That is statistically significant. Systolic blood pressure given in millimeters of males has a mean of 125 and a standard deviation of 14. Calculate the z-score. Oh, z-scores for the male systolic blood pressures, 100 milliliters and 150 milliliters. So for 100,
$1.79.
$1.79. Negative 1.79.
Oh, why is it negative?
Because it's not division number.
100 minus 125.
Oh, 'cause you
whatever is
subtract.
on ours.
Okay, thank you.
Now you can also tell, you should also be able to tell if your sign's correct just by looking at the data. Is 100 less than the mean? So your z-score better be negative.
So mean, anything less than 100. Wait, anything less than mean is
It's going to be a negative z-score.
negative. Okay, thank you.
And you rounded that, right?
Yes.
All right.
And now that's standard deviation, correct? Negative 1.779, standard deviation?
It's unitless, but what that means is that for 100 milliliters systolic blood pressure is 1.79 standard deviations below the mean.
Then 1.79. Yeah. Positive 1 plus.
Oh, I did minus 100.
Yeah.
1.79.
Yeah, 1.79.
Which makes sense, right? 150 is 25 more than 125. 100 is 25 less, so it should be the same z-score, just different signs. The magnitude should be the same.
So being at 150 is over. It
has to be positive.
Okay, got it. Thanks.
If it is the mean, you'll get 0. But that is very, very rare. In fact, it's so rare that if you got a z-score of 0, I would say you cheated to get that data point. That's how rare it is. Look, he's so upset he threw his water on the floor. Don't you dare do that. Don't you dare get a z-score of 0. Oh, look at that. Children. Just kind of use that example. Did you say no more kids? How many do you have?
So I get their personal parts off. Discount.
Elementary school. How old are they? 3 and 2. Soon to be 4 and 3. Oh, dear. Boy and girl too, and they act like they're twins. Mine knows how to open the front door.
Oh no.
Yeah, one day we had someone come up and go, is he yours? You got yelled at. It's an adventure. So what did you get for 11? What's the z-score?
11 minus 10.2.
What do you get as a z-score?
1.
Actually. Just to find information. What'd you get for 7.9?
2.875. Huh?
Negative 2.88.
Negative.
Oh, you rounded up.
All around it's negative 2.88. And what about 12.2?
Six.
It rounded up. Yeah, that's right.
That is not what I got.
I got 2.5, but I guess you rounded up.
That would not round up. 2 decimal places, 2.50.
So it's just 2.5. Okay.
Not six.
No, you only go to 2 decimal places. 2.5 is only 1. So you just leave it as 2.50. 2.599 would be 2.6. And 2.59 wouldn't even be 2.6 because that's still just 2 decimal places.
I have a question, right? So if I was to go on Khan Academy and put this in, what would this be under? Devotion, devitation, standard deviation?
Deviation.
Under
Deviation, thank you.
Khan Academy, this would be z-scores.
Z-scores, okay, thank you.
Continuing to look at graphical displays. Frequency distributions. Typically speaking, frequency distributions is used for qualitative data. Frequency of a category is just the number of times it occurs. And a frequency distribution lists each category and the number of times it occurs. Relative frequency is just the ratio of the frequency to the total. always be a decimal between 0 and 1. This allows us to create what's called a relative frequency distribution, right, which is the same thing, except instead of the frequency, you give its relative frequency. Right, which, simplistically speaking, is just the percent that that specific category occurs. And so you can also do frequency distributions with quantitative data. We examine that a little bit later. Bar graphs is a way to visualize qualitative data. Bar graphs are only for qualitative. Consists of bars separated from each other. Your bars are not connected. That is a histogram that connects the bars. Bars can be rectangles or rectangular boxes and can be drawn either vertically or horizontally. Here is an example. I'd say they took a little bit of liberty with that example. Honestly, with the age groups, that should be they should be using a histogram, not a bar graph, because that is definitely quantitative.
I was about to say that.
That's why I said they took some liberty with that one, but this is definitely, that would definitely be for a bar graph. And again, should be familiar with bar graphs. You see them all the time. Another common one for qualitative data, again, I can guarantee you're familiar with, is a pie chart. So categories of data are represented by wedges in a circle and are proportional in size to the percent of individuals in each category. So generally speaking, a bar graph is going to be from a frequency distribution, and a pie chart, generally speaking, is going to be a relative frequency distribution. Here's an example. And another one. So you could include the percentages on the pie chart. Whenever you do a visual display, you have to be careful. We do discuss this problem next week, but you don't want to purposely misrepresent. Pie charts are really easy to do that with, right? That 59.1%, you better make sure that area is 59.1% of the total circle to be accurate.
you had to display that accuracy when you were in school, like without a graph, right? I mean, without the computer.
Mhm.
So you had to like.
We had
use,
sketch
like-
these, yeah. But again, it was just a rough sketch, so it wasn't too terrible. I mean, I actually couldn't make it 3/4 of the circle. That'd be ridiculous, but as long as it was close, it was fine. Companies always try to mislead you. Even though they're not technically lying. It's just how they represent it. The numbers never lie. It's how you represent those numbers. So create a bar graph. So if we were to sketch it,
Millions would be on the side.
right, your vertical would be
Millions.
millions of diagnoses. It's too much to write down, so I'm just going to write down millions. And your horizontal would be the year. It's your category. .88. Okay, so what I'm going to do is I'm going to say, obviously that's 0. Let's just go up to 1.5 as the maximum. So we'll say that's 1.5. About halfway, I would be 0.75. Well, it kind of looks like half, so I'm going to just take that for my own reference, that is about 0.75. Oh, that means everything's going to be above 0.75. Oh. This sucks. It is what it is. So 0.88.
A little over your
Let's say like that.
Yeah.
And then you have to indicate that is the year 1997. I have to write that very small. I generally want to have it centered. Obviously for, I could probably,
Hard to make. You could just say 97.
I could. But I have enough room on the slide, I could probably make the bars a little bit larger. Let's do something like that.
98 would be a little over 80.
Almost here.
Very slightly over. 1.01. All right, and I'm just going to do this. So on and so forth. All right, you get the idea. course, that doesn't bode well, that the number of diagnoses is increasing every year. All right, now, here's the thing with Excel. It's treating those as numbers. Really, they're not. They're going to be categories, right? The year, for all intents and purposes, is not really a number. I believe it's, of course it's not going to show. Cells, no, it's not cells. No, not format. It's, I definitely want format. Here it is. Right, so cells format. I'm down to format cells. General is default, so it'll choose. I'm going to choose it as text. I want to treat the years as a string, not a number. Hit OK. And notice the alignment changes to signify that. I'm also going to bold those just because I can. I think I'm also going to format these cells. If I click as a number, I can then specify how many decimal places I want it to keep. I will keep it as 2 because that's what the table gave me. And notice that it did change to keep 2 decimal places instead. Highlight those. Insert. This very first one is bar. And then you have your choice. Do you want I see what you're doing. Clever. So what I'm going to do is I'm not going to highlight anything. I have to highlight something. I think I have to adjust the data on my own later. So let's just do that. That's whatever. So you can choose either to do vertical or horizontal. Generally speaking, bar graphs are vertical. Select data. Yeah. Edit. Right, okay, so that's what I want to do, right? So right click, select data. It automatically chooses the scaling. I'm going to hit edit. Select range. Highlight that. Hit OK. Now look, of course, it's counting that year. Of course it is. So let's get rid of year. Will that fix it? No, because it's not giving, okay. So reselect data. So don't choose, oh, crap, no, that. That's that. Edit. Just select the data, not the actual title as well. There's a bar graph. And then you can add stuff, right? So add chart element. Obviously, you want to add axis titles. You want to add them both. So you can rename it. Right, then you can change the color of the bar. You can change layouts. That looks good. Other than, that's a really boring color. Let's do pink. And there you go, there's your bar graph. Picture,
Do you record for us or for your own?
both. At the end of the semester, I have the right to make the recordings public. And so construct a bar graph for that. We kind of, and a pie chart. Yeah, this won't be too difficult.
So the curricular change every year, I'm assuming that?
Hmm?
So the curricular change, like the course change every year?
Type of school. Percent. Oops. Year 56. Plus then year 3 and now notice a problem. It's not really, it's a built-in issue. The text is cut off, right? Now if you click the cell up top, you can still see the full text. It's a nice, easy solution. So it's column A, right? See how the cursor changes? Go up to column A, cursor, you want to be like that. Double click. And it auto sizes it for you. Just so you can see. So let's do bar graph. Select data. Add. Edit. One. What are you doing? Oh, wait a minute. Remove that. I want this one up here. Okay, I clicked the wrong one. That's better. What color do I want this one? So you want the axes. And we'll just put that in here somewhere. It's okay, I'm not an English major, I don't need to know how to spell. It's a percentage of households that have a certain number of working televisions. This time we want a pie chart. And so again, insert, you can probably already see where the pie chart is. Oh, look, that actually did it for me. That's nice. I'm going to change that title though. Percent of households. And again, quick layout, we can change some things. So as you can see, there are layouts to put the percentages. Obviously, having a working legend would be nice as well. So layout 6 kind of looks the best for me. There you go. There's your pie chart. I will not even attempt to do that by hand. Because then I'll spend the next hour trying to draw a perfect circle.
Someone says it's already going to be like written first and second.
What will be?
The pie.
Oh no, if I ask you for a pie chart, you're going to have to sketch it. I'm just not drawing a perfect, so I'm just not drawing circles. I'm a perfectionist, so it would take me forever to get a circle that I actually like.
What about in the exam? What about in the exam? We go to this.
You'll sketch it. Or I could give you a pie chart and ask questions about it. Right, so I could do either one. I could ask you to sketch a graph, or I could give you one and ask you to analyze it. I haven't decided yet. I haven't written the test.
I mean, technically, you can't say it's right or wrong.
Yeah, if you sketch it, you said
Yeah.
you said it yourself when you did it. It wasn't.
It has to be close.
Yeah.
Right. Again, for that green category, the dark green one, you can't have that be 50% of the circle.
Yeah.
Right? It's got to be close. Like I said, I'm just a perfectionist, so. So next up is the frequency distributions for quantitative data. It is not feasible or reasonable to have a category for every single value of quantitative data. Because more likely than not, if you have a data set of 32, you're going to wind up with 32 different categories, each with frequency of 1. So instead, we break the categories into classes, which is just an interval. You want your classes to be equal size, and by that I mean the interval has to be equal length. You typically want it to be like that. You'll probably see some that aren't, which would be misleading. If you do have a small data set of different discrete values, just use the distinct values to create your classes. And so what was it, the tweets one? Right, they're all discrete values like 4, 5, 6, and you have multiples of each one. Just use each number as the class, and then count the frequency that way. That's a relatively small number of distinct values. If your data set is extremely large, or your data is continuous, this is where you do the interval. The smallest value that goes into a class is called your lower class limit. So it would be your starting point for that class. The smallest value that goes into the next class is called your upper class limit. And the difference in that value, so the upper limit minus the lower limit, is your class width. And again, you want each class to have equal width. And I believe this is going to be the first time there's going to be a difference in representation. She uses a specific symbol that does not exist in LaTeX.
When you say she, who is she?
The course coordinator.
Oh, okay.
The one who wrote the course.
Yeah, I was in her class.
Nah, sorry, it's the same exact notes. It's literally the same exact course. I do try to put a little bit of a spin on it, as much as I can. Histogram is for quantitative data. Specifically, we read it from a quantitative frequency table, and it's very similar to a box plot. Not box plot, I'm sorry. Bar graph, except your bars are now connected. And your bars are also going to represent classes, right? So if you notice, 10 to 13, that's the first class. 10 to 13. That's why you connect in a histogram. So it starts at the lower class limit, ends at the upper class limit. Next bar would start at the lower class limit, which is the upper class limit of the previous, right, to its upper class limit, so on and so forth. Here's the difference in symbols. And this is how it will be in the notes that are online. Notes, right? Something like that. Which is not a recognized mathematical symbol. Which means there's no LaTeX code for it. And I use LaTeX to type up my notes. So that is read $250 up to but not including $260, which is exactly how interval notation works. Where the closed bracket means endpoint included, and open bracket means endpoint is not included, so it will go up to, but not including 260. So why we don't just use that when that is the accepted statistical symbolism, I don't know. But I'm not a coordinator, so. Lower limit of the 6th class.
Is it 3? No,
It's
3
it's 5.
is 5.
5 to
You're giving me frequency.
It's 3. No, 300.
so yeah, it's 3. Yeah, 300.
$300 is your upper,
Yeah.
Okay.
or is the lower limit of the 6th class.
Okay. Yeah. And then your little arrow you did 310.
Well, no, I just want the lower limit in this case, so it's just 300. So that class values would start at $300. Upper limit for the 4th class, $290. What is the width of the 5th class?
Bless you.
$10.
How do you find that? Oh, never mind.
Upper minus lower.
Yeah.
Uh-oh. Oh, perfect. Okay, good. Did reset. No, it didn't. That should not be there. Let's go. Oh, no. No. But I was right. No, we'll see what happens if I write, see if that 0 goes away. If not, I'm going to have to restart PowerPoint. It was doing this to me a lot in pre-calc this morning. Frequency and relative frequency of the 3rd class.
10.
Oh, no. Okay, so for some reason there's an extra 0 there under 3rd, and I don't know why, and I can't erase it. I don't think it'll even let me select it. Will it? No. If I move you, no, it won't let me select it. And I'm not restarting just for that, so. But now it won't let me erase that F. That's not good. That F isn't even showing up. I do have to restart. That is truly annoying. I don't know why it's been doing that. So frequency for the 3rd class. What's the relative frequency?
10. Oh, 3rd class. Oh.
What is it? 16 over?
Yeah, so it's 3rd.
I agree, 16 over something.
7.
Some of all frequencies.
Which is what?
You added.
Yeah,
Yeah.
that was what I did.
16 over 65?
Over 65. How'd you get 65?
It's less.
And it tells you how many there are.
Oh, okay. You said something?
Tells you there's 65 employees, so you don't need to sum up the frequencies. So 16 over 65. And as a general thumb, 4 decimal places. That's what I keep it as. So 0.2462. Or 24.62%.
So frequency is, well, relative frequency is the frequency.
Divided by total. Construct a frequency distribution. I'm going to cheat a little bit. I'll just use the table that I already have. So here's what you want to generally do. First, how many classes do you want?
5.
My table gave 7. So I'm going to stick with 7 classes. But there's really no rule. How many classes? Which means I probably tell you on a test how many classes I
So
want.
how do you find the classes?
Well, first you have to decide how many classes you want.
Oh, so you just make your own.
8. So the chart I have uses 7, so that's what I'm going to go with. 7 classes. You need a width for each class. Maximum minus minimum, so take the range and divide it by the number of classes you have. That would be your class width.
So
What was that?
Can you say that again, please, so I can write it down?
Yeah.
You said class what?
Class width is range divided by the number of classes. So in this case, it winds up being a class width of 8. Start with the minimum value. At 8. I'll try and use the terminology of the notes here. It just doesn't look right. I think it's more something like that.
how did you get the minimum value for 118?
From this chart. You look.
It's the minimum 118.
It's not there.
No, it's 119. So why are they starting with 118 here?
Yeah.
119.
I don't know why they're starting with 118
I
here.
don't know, we can go with 119.
Oh! I know why. What's the largest value?
176.
Oh, it is, so then why is it doing that? Why is it going to 180?
176. Yeah.
I thought it was 179. Why is it going to 180? Because you want your final class to have an upper limit that's larger than your largest value.
That's how you get 118.
And do you round that?
How come?
Depends. Because remember, the upper class limit is not included. So if you have your final be something like this, 176 would not be included in that class. Your largest value is being excluded.
Where did you get the 118?
That's just what my chart's using.
You said, huh?
That's what the chart that I have is using. I don't know where they got it from.
Well, I think because if the lowest one,
What replaces 118?
It's supposed to be 119.
Oh, yeah,
It's
that's
supposed to be the smallest value.
Yeah.
But 126 is good, right?
And so 176 minus 119 is 57. Oh, I see what they did. 57 does not divide by 7. $56 divides by 7.
Yeah.
So that's what they did. They then just said, okay, well, we're just going to use a class width of 8, which then reduced everything. That's what they did. Because they're all whole numbers. Right. Yeah, that's what they did. That's annoying. 57 over 7 is 8 and some change. You could use a decimal as your class width, that's fine. Problem is, all of these are whole numbers. So they kept it as a whole number, so they used a class width of 8. And then started at 118 instead of 119 because of that. You could do 119. Use that as your lower limit. You should still get the same thing. So that's what I'm going to do. I'm just going to say, okay, well, I just picked 118. So that's where I want to start. Right, but again, you want that value to be less than your minimum value, either less than or equal to your minimum value for your first class. Add 8. What are they doing? So this is what we're going to do. Because they're screwing up. 119 at 8, 127.
So you will add 9, right? 8 still?
8, yeah, I'm still using 8 as my class width. 127 at 8. Right, 135 at 8.
And what is this called?
143 at 8. This is a frequency distribution.
Thank you.
151, add 8.
Yeah, I don't want to have something.
One 59, add 8, 167,
One more.
which does not give me the 176. 7. No, whatever, don't care. Add 8. 1,
83.
83. There we go, we're using 9, don't care. Or, I think that's 8, right? 8, that's whatever, don't care. Using 8. Doesn't matter. Purposes are still served. Then what you have to do is count the number of values you have within each interval. So how many data points are between 119 and 127, not including 127? That's what would go,
It's 7.
that's what would go here, whatever that number is.
Okay. So like it's 0.
Between 118 and 126, they have 3, right? So I put 3. I'm not going to sit there and count every single value.
Can you please explain this again?
So now you have your classes. You just count the number of values that fall in each class. Right? So you come back to your data set. How many are 119 to 127, not including 127? That would be your frequency for that class. Right?
For that one, we have to put in the order, right?
You don't necessarily have to have it ordered. It would make it easier to order it,
Yeah, because it's just,
but you don't have to.
okay.
This one's easy.
This is easier.
That one's easy. Because the classes are just going to be 0, 1, 2, 3, 4, 5. And then they tell you the frequency of each one. And then the histogram for that would be easy as well.
That is a really understanding.
So do we take the quiz at home?
Yes, it's all on the quiz is online. I just want to see what's on the quiz. Actually, I can just look.
Wait, so that first quiz we did, that was like a real quiz?
Yep.
You gotta reconsider a lot of that one.
I don't